Hello everyone. Today we are going to learn 9.3 estimating population means. So we have an objective here, learning objective. Okay, so this is a very similar concept with population proportion, estimating population proportion. So we just changed the population mean, but there's a slightly different about the critical value because we used z critical value, right? But here we are going to use the t critical value. That's why I mentioned the z earlier. And then we will learn t. And then we talk about t score, t value in the chapter 8, right? T distribution. So Gasset, he could not publish on his name because he was working on the company, brew, the beer company, right? Was Guinness, right? Yeah. So he could not publish it on his name. So the company did not want to uh, expose their company's some secret whatever. So he's using the name, which is a student's T distribution, right? Okay, so let us do this one. We have lower limit, upper limit. So we have X bar. That's the point estimate, right? So point estimate. So we are using just mean, sample mean. Yeah. And then lower limit, and subtract the margin of error, and upper limit, add margin of error, right? Okay, student T T distribution. All right, so once again, we have to have a normal distribution. So in that case, how do we check? We had earlier n times p hat. Uh, sorry, what was it? Oh my gosh. N times p hat, 1 minus p hat. N times p hat, because I was using p hat, that's why a little bit cannot not refresh. So n times p, normally we have 1 minus p, right? Greater than or equal to 10, right? Earlier, but then p is not given, so we are using p hat, right? Yeah, that is the one. Here, how do we check whether normal distribution or not? Sample size again, right? So bigger enough. How much bigger? Then n is must be greater than or equal to 30. Yeah, we have a different formula. All right, then we have a t distribution with n minus 1 degree of freedom, right? So the name of n minus 1, yeah. All right, then when the sigma unknown, we are using S, right? So we are using S over square root of n. Yeah, all right. So that is come from z-score, right? So z-score, we have x minus mu over sigma, right? Then in the sampling distribution, we have z equal to about the sample mean x bar minus mu sub x bar over sigma sub x bar, right? Okay, so x bar, we are using that. What was the mu sub x bar? It's mu. What was the sigma sub x bar? Over sigma over square root of n, right? Okay. Then what's the difference between t value and z-score? Only this one different, right? So if we know the sigma, we are using z-score. If we don't know the sigma, we're using t-score, t value. All right? Okay. Now, we knew that when t distribution getting bigger, become normal distribution, right? That's why we check that big enough. How much big enough then? And it's greater than or equal to 30, right? Otherwise, the normal curve, no, sorry, the t distribution has more wider, right? So between -10 to +10, when z-score is between -3 to the +3, right? Okay, so yeah, there we go. So t distribution between, which one is t? So the red one is t, purple is t. So red one is t, so -10 to +10. Normal distribution is blue, so normally between -3 and +3. But then we're still using, we are using software, right? So we still can find, even though z-score is below -3 or more than +3, we still find the area. The area will be 0.00000000001, like that. Okay? All right. The definition again. So we have a t sub alpha over 2. It's a t-score, t-value, right? With the n-1 degree of freedom. So same as the z critical value. They talk about area of right tail, right? So does here. So what's the t sub alpha over 2? It's the area of right tail. All right. So we have the nice picture, right tail. Or we can use it between two, right? So 1 minus alpha, like what we did last section. Okay, so margin of error again, right? So margin of error for population mean. So we are using t critical value and standard deviation. So t critical value. Okay, let me using just this one, standard error. Yeah. So we learned previously what was the standard error, right? So how much is spread about sample to sample, right? Yeah. Okay. Now let us do this one. Let me arrange a little bit. All right, so let's do this example. So we have a 95% confidence interval and sample size n equal to 22, right? Okay, so let's using StatCrunch. So we have n minus 1, which is 22 minus 1 equal to 21 degree of freedom, right? All right, so alpha over 2, how do we find? So alpha, which is equal to 100% minus 95%, so 5%, right? So alpha over 2, so alpha over 2 is 5% over 2, which is 2.5%, right? So each. So that will be 0.12, so 0.025, right? 0.025. Okay, so let us do seconds. Let me show you just one. Okay, so I want to use a share screen here. What was it? 95%. 0 point. Let me take a picture. I might not remember. Okay. All right, so where's the yeah, StatCrunch here. Okay, open StatCrunch. We go to stack, calculator, and then T, right? So let me highlight. Hold on 1 second. I'm not sharing, huh? So we go to stack, calculator, T. Oh, where it go? Hold on 1 second. Calculator T. Yeah. All right. All right. So let me click that T. Okay. So I want to put right click, right? Right click. Degree of freedom is 21. Hold on 1 second. 21. And then right tail, right? So area of right tail, not right click. And we want to know about the t-score, t-value, right? So we want to know about that, right? And then area of right tail is 0.025. 0.025. Compute. Okay, t-value is 2.079. Yeah. Once again, t-value is the same as z-score. So sometimes 2 decimal places, sometimes 3 decimal places. All right. So let's see. Now this one, oh, we don't use 95%, right? Yeah, it was, right? 95. Okay. Let me see. Yeah, I'm checking. 2.0796. Yeah, they're using 4 decimal places. Okay. Now, since I'm here, I'm gonna show you other way we can find. So we can find like between. So between. So 95%. So we're using 95% means 0.95. So 0.95. And then this will be T, right? Then compute. Look. So we are using only the positive part. Oh, that's why they were using 4 decimal places because they give us 4, right? Yeah. Since we talk about the area of right tail is positive, right? So that will be that, right? So 2.0796. Yeah. And then this will be negative 2.0796. Clear? Okay. Either way we can find. All right. Let me go back. All right. So let us do estimating confidence interval for the population mean. Yeah. Okay, so this is a process. If the parent population means that original population, original distribution is normal, or the sample size is n greater or equal to 30. This is from the central limit theorem, right? For population mean, yeah. So we have a two part of a central limit theorem. This is for part two, right? Okay. We check that that is normal, right? And sample mean, export, and then sample standard deviation, calculate if we need, and then identify the confidence level, and then the t distribution, t score, t value, alpha over 2, right? And the degree of freedom, df, and then find the t score, and calculate the margin of error, and lower limit, upper limit, and then conclusion, right? Okay, so let us do that. This is the same as the process. Okay, so we have this question. A random sample of 40 patients tested for HDL cholesterol had a mean level of 50.7 milligrams. So HDL cholesterol is a good cholesterol, but it must be balanced with LDL cholesterol, right? Bad cholesterol, yeah? Okay, so then milligrams per deciliters and standard deviation 11.85 milligrams per deciliter. Find 95% confidence level with for the population mean HDL cholesterol level for the population of patients, yeah? And then we want to find confidence interval, right? Okay, now step one. Step one say that we want to find sample size, sample mean, sample standard deviation, confidence level, right? Okay, so let us do that. Number one, n equal to, what do you get? 40 there, 40 patients, and then export, mean 50.7, right? So milligram per deciliter, and standard deviation 11.85 milligrams per deciliter, right? Okay, how many for confidence level, right? So 95% confidence level, yeah. Okay, number two, what we have, make sure that parent distribution is approximately normal, or sample size n is greater than or equal to 30, right? We don't know about the parent distribution is normal, but we know sample size is 40, right? N equal to 40, which is greater than or equal to 30. So it's a normal distribution, right? All right, then number three, find the value of t sub alpha over 2, so level of confidence you want. All right, so number three, if we're using between them, much easier, right? So look, 95% confidence level. We are using T calculator, using between, and then we put the 0.95. So degree of freedom, how much degree of freedom? 40 minus 1 is a 39 degree of freedom, right? And we put the probability and t between, right? So between, we want to find, right? That is the, we can use seconds, and then 95% confidence level, we put the here, right? Okay, can anyone do for us? No, we don't have to calculate that, right? Ah, alpha over 2. Anyway, we calculate later. Okay. All right, so let's do it. StatCrunch, yeah? One more time, I'm gonna show you. All right. Share. Okay, so we have a between there, and then 39. 39. And then we want to know about the t-value, right? T-score. So make it empty, and 95% level of confidence, there will be here, 0.95 probability, okay? Compute. And then we are using the positive because the area of right tail, right? So 2.0227. So we are going to use that, 2.0227. So basically, there is a t-score, t-value, yeah, using that. 2.0227. All right. So because we want to only the area of right tail. Okay, let's go back. All right, so number 4, we are going to find margin of error, right? So margin of error. So basically, t critical value times the standard error, right? Okay. Margin of error, number 4. Margin of error, t value with standard error. So there is t-value and standard error is s over square root of n in the case. All right, so we are using 2.0227, and then s we had earlier, so 11.85 over square root of 40, right? Then what do you get? We get 3.7898. Yeah. Okay, so the last one, number 5, lower limit, upper limit, right? So lower limit. Okay, let me do it. Lower limit. So that is x bar minus margin of error. So x bar we had 50.7. 50.7 minus margin of error 7898. What do you get? 46.91, and upper limit x bar plus margin of error, so 50.7 plus 3.7898. We have 54.49. Yeah. Okay, so conclusion, right? So we don't know what exact value for the population mean is. Population mean is a little bit smaller. Mean is, but we are how much confident? 95, 95 confidence. 95 confident that the true population mean, then we are using their word, right? Where is it? Population mean HDL, HDL cholesterol level for the population of patients. Between, it's between, yeah. Then we read their lower limit, upper limit, right? So population mean, cholesterol, HDL. Yeah, HDL cholesterol. HDL cholesterol, HDL cholesterol level for patients is between, okay, so times 100%. No, that's not the proportion, right? Sorry about that. It's just a we read. This is a mean, right? So 46. 46.91 and 54.49. And we can add a unit. Milligrams per deciliter, right? Yeah. Okay, makes sense? Very good. All right, so let us do StatCrunch, yeah? So StatCrunch, how to do it. So same. All right, so let me do share StatCrunch here. Okay, so let me do from here. Open StatCrunch, go to Stack, and T stacks, yeah? And one sample, and then with a summary, yeah? So we had experience before when we had a hypothesis test for mean, right? Okay, so let me click. Okay, then sample mean. Sample mean, we have 50.7. Sorry, I have a lot of things on the screen. I need to move around. 50.7. And then sample standard deviation, 11.85. And sample size, n equal to 40. And then confidence interval, yeah? 95%, right? Okay. Maybe show critical value so that we can find the margin of error. All right. So this is the one lower limit, upper limit, right? Okay. Yeah. So let's try margin of error, right? So margin of error. So we can try from upper limit minus x bar, right? So that will be 54.48 9814 minus x bar 50.7. Yeah. Let me calculate. We have 54.489814 minus 50.7. Yeah, 3 point. Do I get the 3 point? Yeah, 7898. Excellent. It's exactly same. Yeah. Okay. Then can we try or what is called margin of error t is alpha over 2 times standard deviation, sorry, standard error, right? There will be critical t, which is 2.02260909, and standard error here 1.8736495. Yeah, I want to keep the everything so that I can whether I want to know about the exact number, right? So 2.0226909 times 1.8736495. Yeah, exactly same. If we make 4 decimal places, so 3.7898. We have the same as here, 3.7898. Yeah. Yeah. So there is two ways we can find the margin of error by the StatCrunch. Little bit work, right? But better than by hand everything, right? Yeah. This is the way. So same as the earlier section, we can use that, but you have to click critical value earlier, right? Before you getting into this screen, right? Makes sense, right? Okay. Let's go back. Okay, so let us find this confidence interval by StatCrunch. So look at this one. We have data, right? So we're following same instruction or steps earlier, like with the summary, right? But we changed that the last step with the data. Yeah. Okay. But then we noticed that I think we did this one before, right? So high school GPA versus college GPA, right? Okay, so let us do that. StatCrunch. All right, so let's do that. OpenStax. Okay, so there is data. So let me copy everything, or we can do one by one, right? So because we don't need the two at one time, it's up to you. Copy and paste. All right, go to stack. Ooh, go to stack. T-stacks. One sample with data, right? Okay. Let me highlight stack, T-stacks, one sample with the data. Yeah, let's click that. All right. The first one, high school GPA, right? And then we want to know about the confidence interval. Yeah, if we want to know about the margin of error, yeah, the T score, the T value. Okay, let's compute. All right. So we have a lower limit, upper limit here. Yeah. So we can find the margin of error. This is a t-score, t-value, right? Degree of freedom. So n equal to 48 then, right? And this is a sample mean and standard error, right? Okay. Let's find the college. Yeah, so let's leave here and then college. So go to t-stacks and one sample. Ooh, one sample and we do data, right? Click that. All right, so college GPA and same process. Oh, did I do 95%? Was it 95%? Yeah, it is 95%, right? Yeah. Okay. Then critical value, if you want to calculate the margin of error, right? So compute. Yeah, I did. I was crazy. So yeah, I can see that. 95% confidence. Yeah. All right. So here is the lower limit, upper limit. Here is a lower limit, upper limit for this is the college, right? So this is high school. This is for college, right? Yeah, right. Okay. So lower limit slightly higher for the high school, upper limit also slightly higher rather than college, right? Okay. So let's go back to lecture note. Okay, so let's take a look the confidence interval, right? So this is the actual interval, right? So the high school GPA, so this is 2.98 between 3.39, slightly higher than college students GPA, right? So college students GPA is 2.83 between 3.18, right? Okay, so what this means? So notice that two confidence intervals overlap, right? So indicating that there may be no difference between the mean GPA for high school or college students. So we will study more about in chapter 10 about the two samples. Okay? All right, so let us do sample size for the mean. Yeah. So once again, this is from oh, you know what? Looking at this one, this is we're going back to Z-score. Yeah. Can you see that? Yeah. So let me see. All right. So why are we going back to Z-score? Z critical value, right? Uh, not the T, right? Because we are dealing with the T distribution, T score, T value, right? Okay, so when we use T value, T score, we have to have a degree of freedom. That means we have to know about the N, right? Sample size. Make sense? Yeah. And then also T distribution, when N is getting bigger, it become T distribution become Z normal distribution, right? When this one happen, when N is greater than or equal to 30, right? Or parent population is normal distribution, right? That's why we are using Z score here. Make sense? Okay, let me write down for you. All right, so I wrote down here, so we have that. And then sample size, we have this one. Okay, since we are using z-test, no, sorry, z critical value, right? So we have to know about the level of confidence with z's critical value, right? So basically there is more confidence level, but then in general, we are using most 90%, 95%, 99% here. But we know how to find the 91%, 92%, 93%, and so on, right? Okay. We can use area of right tail or between using these numbers in the area, right? Okay, now let us do this one. Let me make another. Okay, so let me arrange that. All right, so let us do this one. Sample size, find the sample size. So we should know what is the Z critical value when the 95% confidence level, right? So 95% confidence level, level. It's a 1.96, 1.96. And over the margin of error, where is margin of error? Let's see. Oh, error less than 1,000, right? So that is margin of error. And then S, the standard deviation, we have 20,000. Yeah. I don't want to put the comma, right? People think that's the decimal, right? Okay, then don't forget we have a square, right? Okay, now what do you get? 1536.64. Then we do round up all the time because the sample is always items or the people, right? So more sample, more accurate, right? Oh, yeah. Yeah, right. So 1,537, always round up, right? Well, always round up, right? Okay, up, not the round off. Okay, now we can find the sample size by StatCrunch as well, like earlier section, right? Okay, so just so we do remember the margin of error, it should be double, right? Okay, let me take a picture. Which is margin of error? This is a 0.25 is margin of error, right? Okay. Then we have a 95% confidence. And what information we need? And confidence, yeah, standard deviation. Standard deviation, where is the standard deviation? Hold on one second. Prior, prior, each is about 2 standard deviation for, yeah, standard deviation for number is the 2 hours, yeah. Okay, so we need this information. So we have a standard deviation, we have a 95% confidence level, and then margin of error is 0.25. 0.25 times 2, right? 0 times 2, so that's a 0.5. We are using that. Double. Yeah. Okay, so double with double with 0.5. Oh, here we go. Yeah. All right. So let's do that. Then we are done. Yeah. Okay. Very good. So let me show you StatCrunch. Then we are done for this section. Okay, so this one, right? Oh, let's do here. And then I need to turn off here too. Okay, so stack. We're doing T stacks, right? Oh, hold on 1 second. Sorry about that. Stack and I thought I said seconds, right? Okay, so we go to stack and T stacks, one sample and then width, right? Stack and T stacks, one sample with sample size. Click that. Yeah. All right. Confidence level 95, right? So we can just keep that. Standard deviation was 2, right? And the width 0.5. So double of, remember, double of the margin of error, right? In that case, we had a 0.2, 0.2, 0.25, right? 0.25. So times 2. So 0.5, yeah, double. Okay, now we want to find the sample size, so we make empty sample size and compute, right? Okay, 249. So this one is already rounded up, so we don't have to worry about that. Already up. Yeah, round up. Let me write down round up. Okay, so thank you for watching. I will see you in the next video. Bye-bye. Oh.